Somewhere in the universe, there is a darkness so complete, so absolute, that light itself cannot find its way back. Not the darkness of a moonless night, not the darkness between stars. Something older, something heavier, something that does not reflect, does not emit, does not betray its presence by any ordinary means. And yet, around it blazes a fire so violent it outshines 100 trillion suns. A fire that has been burning for 10 billion years. A fire so bright it can be seen from the opposite side of the observable universe, visible to the naked eye of any civilization, patient enough to build a telescope and point it at the right patch of an otherwise unremarkable sky. At the center of that fire is a void, not empty space, something far stranger. A region of the universe where mass has been compressed so completely that space itself has broken down. Where the laws of physics, as we understand them, simply stop working. A black hole. But not just any black hole. The largest, most monstrous, most gravitationally extreme object humanity has ever confirmed to exist. Its name is TON 618. And once you truly understand what it is, how large it is, what it does, what its existence even means, the universe will never feel quite the same again. It begins, as so many of the universe's greatest secrets do, with a mistake. A small observatory in the mountains near Puebla, Mexico. The Tonantzintla Observatory, named for the town below it, a place of colonial Baroque churches and high desert air, is conducting a survey of faint blue stars in the northern sky. The astronomers Braulio Iriarte and Enrique Chavira are cataloging objects that appear bluish or violet on their photographic plates. These are mostly white dwarfs, the dead, cooling cores of stars that have burned through their fuel. Small, common, well understood. One object stands out. Entry number 618 in the Tonantzintla catalog. Faint, blue, compact. Nothing particularly notable about it, except the intensity of its color. They write it down, move on. Nobody knows what it really is. Nobody can, because the concept of what it actually is, the entire framework of understanding needed to recognize it, doesn't yet exist. The word quasar won't even be coined for another 6 years. And so TON 618 sits in a catalog as a misidentified dead star. Its light, which has been traveling for 10.8 billion years to reach that photographic plate, recorded and filed away. Its true nature completely invisible to the people who first captured it. 13 years pass. In 1970, a radio survey conducted in Bologna, Italy, sweeps the same patch of sky. And from the coordinates of entry 618 in the Tonantzintla catalog comes something a quiet white dwarf should never produce. Radio waves. Intense ones. The kind only generated by the most violent processes in the universe. Something is very wrong with this star. Or rather, something is very, very right. Before we go further, we need to understand what was discovered that night in Bologna, because quasar is one of those words that gets used casually without most people fully grasping what it means. And with TON 618, the details matter. They're what make it extraordinary rather than merely distant. At the center of almost every large galaxy in the universe sits a supermassive black hole. Most of the time, these black holes are quiet. They've consumed the gas that was immediately available to them, and now they sit dormant, enormous but passive. Our own Milky Way's central black hole, Sagittarius A, is one of these, massive by human standards, about 4 million times the mass of our Sun, but quiet. In the early universe, things were different. Galaxies were young. They were dense with gas. Vast clouds of hydrogen and helium left over from the Big Bang, still collapsing, still available as fuel. And when that gas begins falling toward a central black hole, it doesn't fall in quietly. It forms a disk. The gas swirls inward in a flattened spiral, an accretion disk, and as it does, particles collide with each other at enormous speeds. The friction generates heat, not the warmth of a campfire, not even the inferno of a star's core. Something on a completely different scale. The innermost regions of an accretion disk, around an actively feeding supermassive black hole, can reach temperatures of tens of thousands to millions of degrees. At those temperatures, the disk radiates across every wavelength simultaneously. Visible light, ultraviolet, X-rays, radio waves, all of it, blasting outward with an energy output that can exceed the combined light of every single star in the surrounding galaxy, by a factor of hundreds. This is what a quasar is, not the black hole itself. The blazing, violent, ultra-luminous spectacle of matter falling into a black hole, heated to extremes, compressed, and converted into pure light and radiation before it crosses the point of no return. And TON 618 is not just a quasar. It is the most powerful example of one of the most extreme categories of quasar ever found. Hyperluminous, radio loud, a cosmic engine operating at the very edge of what physics permits. When Marie-Hélène Ulrich pointed the McDonald Observatory Telescope in Texas at the coordinates of TON 618 in the 1970s and spread its light through a spectrograph, what she found ended all doubt. The emission lines in the spectrum were shifted massively toward the red end. A redshift of Z equals 2.219. That number means TON 618's light has been traveling for approximately 10.8 billion years to reach us. We are seeing it as it appeared when the universe was only about 3 billion years old, less than a quarter of its current age, long before our sun existed, long before the rocky planet it would eventually warm had any reason to form. And yet, from that unimaginable distance, TON 618 is bright enough to be detected by telescopes built in the 20th century. Not just detected, studied in detail. That is because of what it is doing. TON 618's luminosity, the total power output of its accretion disk, is equivalent to approximately 140 trillion times the energy output of our sun. Not the Milky Way, not a cluster of galaxies, 140 trillion individual suns, all blazing simultaneously, all concentrated around a single point in space. Its absolute magnitude is -30.7. On the scale astronomers use to measure brightness, our own full moon sits at -12.7, a difference of 18 magnitudes, which, in the nonlinear logarithmic system astronomers use, means TON 618 is roughly 25 million times brighter than the full moon, measured from a standard astronomical distance. If TON 618 were placed where our nearest star, Proxima Centauri, sits, just 4.2 light-years away, it would cast shadows at night, every night, perpetually, a second sun, one that never sets, blazing in our sky with the light of 100 trillion stars compressed into a single point. But our nearest star is not where TON 618. It is 18.2 billion light-years away, and even across that distance, it glows. Now we arrive at the number that defines this story. The mass at the center of TON 618. Estimates vary somewhat depending on the method used. The most widely cited figure, derived from measuring the width of the H-beta emission line in the quasar's spectrum, one of the most direct tools available, places the mass at approximately 66 billion times the mass of our Sun. A more recent analysis, using a different spectral line, suggests a figure closer to 40.7 billion solar masses. The true value probably lies somewhere in that range. Let's use the conservative figure, 40 billion solar masses, because even the lower estimate is almost beyond comprehension. The entire Milky Way galaxy, every star you've ever seen on a clear night, every sun in the spiral arms, everything that comprises our home galaxy, contains approximately 200 to 400 billion individual stars. Their combined stellar mass is estimated at around 64 billion solar masses. TON 618's black hole, on its own, contains mass comparable to the total mass of every star in our galaxy, all of them combined. You are not looking at a black hole sitting inside a galaxy. You are looking at a single object with a gravitational grip on par with an entire galaxy's worth of stars. Wrapped in darkness, invisible to direct observation, betrayed only by the violence of what falls toward it. Now let's talk about its event horizon. The event horizon is the point of no return, the radius from the black hole's center within which nothing, not even light, can escape. For TON 618, that radius is approximately 1,300 astronomical units. 1 astronomical unit is the distance from the Earth to the Sun, 150 million kilometers. 1,300 astronomical units. The event horizon radius of TON 618 is 195 billion kilometers. The diameter, rim to rim, is roughly 390 billion kilometers. Light, moving at the fastest speed anything in the universe can move, would take approximately 15 days to cross from one side of TON 618's event horizon to the other. Our entire solar system, from Mercury to Neptune, is only about 60 astronomical units across. The Kuiper Belt, where Pluto orbits, stretches to about 50 astronomical units from the Sun. The event horizon of TON 608 is more than 25 times wider than the entire planetary region of our solar system. If you placed TON 618 at the center of our solar system, its event horizon would swallow Mercury, Venus, Earth, Mars, the asteroid belt, Jupiter, Saturn, Uranus, Neptune, Pluto, and continue expanding into the Oort cloud beyond. Every planet, every moon, every asteroid, every object that has ever been part of this solar system, gone, inside it, without a trace. Around that darkness spins the most violent environment in the observable universe, the accretion disk of TON 618. Gas and dust, drawn in by the black hole's gravity, spiral inward in an enormous, flattened disk, like water circling a drain. But the drain is 40 billion solar masses, and the speeds involved are a fraction of the speed of light. Measured spectral lines from TON 618 show gas moving at speeds of up to 10,500 kilometers per second. That's roughly 3.5% of the speed of light, fast enough to circle the Earth in less than 4 seconds. Gas at those speeds, colliding with other gas, generates friction that heats the inner disk to temperatures of tens of millions of degrees. At those temperatures, matter behaves in ways nothing on Earth ever will. Electrons are ripped from atoms. Magnetic fields build and coil through the turbulent plasma. Radiation pressure becomes a physical force, pushing outward against the inward pull of gravity. The entire environment is a feedback loop of violence. Gravity pulling in, radiation pushing out, and the disk caught between, radiating the energy of that ongoing struggle across every wavelength the universe allows. But perhaps the most extraordinary thing the accretion disk produces is not the disk itself. It's what gets launched out of it. When the magnetic fields coiling through an accretion disk become organized enough, they can funnel material along the rotational poles of the black hole and accelerate it outward at relativistic speeds, near the speed of light. These are relativistic jets, and the jets of TON 618 are among the longest, most energetic structures in the known universe. Plasma and charged particles, launched at close to the speed of light, blasting outward from both poles of TON 618. Each jet stretches for hundreds of thousands of light-years, larger than entire galaxies, carrying enough energy to sculpt the space around them, heating intergalactic gas, carving enormous cavities in the matter surrounding the host galaxy, even, in some extreme cases, halting star formation across an entire region of space, because the jets heat the gas reservoirs that would otherwise collapse into new stars. A black hole that cannot be seen, reshaping entire regions of the universe through the violence of what it's devouring. There is something else surrounding TON 618 that wasn't known until 2021, something that, in its own way, is almost as extraordinary as the black hole itself. When astronomers turned the ALMA telescope array, the Atacama Large Millimeter Array, a network of 66 radio dishes spread across the Chilean desert, toward TON 618, they found it surrounded by an enormous cloud of gas. Not the accretion disk, not the jets, an entire nebula, a Lyman alpha blob, one of the largest known structures of this type in the universe. Its diameter, at least 100 kiloparsecs, which translates to roughly 330,000 light-years across. The Milky Way, our home galaxy, stretches about 100,000 light-years from end to end. TON 618's surrounding gas cloud is more than 3 times wider, more than 3 times larger than the entire galaxy you live in. This nebula contains 2 distinct components: an inner region of hot molecular gas being blasted outward by the jets, an outflow carrying mass equivalent to tens of billions of solar masses, and an outer region of cooler gas in the circumgalactic medium aligned with the jet direction, equally massive. The nebula glows in ultraviolet, specifically the Lyman alpha emission line of neutral hydrogen, lit up from within by the ferocious radiation of the quasar at its center. A cloud of gas, 3 times the width of our galaxy, glowing in ultraviolet, surrounding the most massive black hole ever confirmed, and all of it invisible to the human eye. Too far away, the light shifted far out of the visible spectrum by 10.8 billion years of cosmic expansion. We detect it only because our instruments are built to find what our eyes cannot. Let's go there. Imagine you are approaching TON 618. Not falling in, not yet, just approaching, closing the distance from the surrounding emptiness toward the blazing accretion disk. From far away, the quasar is simply an impossibly bright point, blinding, more radiant than anything else you can see in any direction. As you close the distance, structure begins to emerge. The disk resolves, an enormous, flattened ring of glowing plasma, rotating so fast at its inner edge that the material is moving at a meaningful fraction of the speed of light. The disk is not uniform. It has texture. Inner rings brighter and hotter than outer ones. Spiral features carved by magnetic instabilities. Clumps of denser gas catching and releasing light in complex patterns. And at the center of all of it, nothing. A sphere of absolute darkness, surrounded by fire. The accretion disk wraps around it, but the black hole itself emits nothing. Not a photon, not a trace of radiation. It is the most complete darkness that physics permits to exist. But the darkness is not featureless. Light from the accretion disk, bent by the black hole's gravity, curves around behind it. Rays of light that would normally travel away from you are pulled back into a halo, a ring of light appearing around the shadow, formed by photons trapped in circular orbits before finally tumbling inward. This is the photon sphere. The gravitational lensing of a black hole this massive would be visible from enormous distances. A bright ring outlining the perfect circle of darkness at the center. As you approach the event horizon, colors begin to shift. The intense radiation near the black hole's surface is gravitationally redshifted, the light stretching to longer wavelengths as it climbs out of the gravitational well. From outside, light near the event horizon appears to fade toward deep red, then infrared, then beyond detection. The black hole seems to drain color from the universe around it, and time begins to change. For an outside observer watching you approach, your clock appears to slow. At the event horizon itself, from their perspective, you would appear frozen, suspended at the boundary forever. Time itself, in the presence of gravity this extreme, does not flow at the same rate for everyone. For you, falling inward, you would cross the event horizon without any dramatic physical sensation. No wall, no sound, no flash of light. Just a moment of crossing, and then the universe above you, entire and complete, visible in a shrinking circle of light that grows smaller as you fall further in. Below the event horizon, there is no escape, not because of speed, because the geometry of space-time itself has been rearranged. All paths lead inward. Every direction, including what used to be up, curves toward the singularity at the center. Physics, as we understand it, breaks down there. What happens at the singularity is a question we cannot answer, because the mathematics we use to describe the universe simply stops producing meaningful results. Now, the question that haunts every paper written about TON 618. How does a black hole grow to 40 or 66 billion solar masses? In a universe only 3 billion years old at the time. Start with a basic fact. Black holes can only grow so fast. When a black hole feeds from an accretion disk, the radiation the disk produces pushes outward. The brighter the disk, the more material falling in, the stronger the radiation pressure. At a certain accretion rate, the outward radiation pressure exactly balances the inward gravitational pull, and the disk can no longer compress more material inward. This is the Eddington limit, a theoretical ceiling on how fast a black hole can grow by ordinary accretion. If you apply the Eddington limit to a typical seed black hole, a few hundred solar masses, perhaps from one of the very first stellar collapses, and you grow it at the maximum allowed rate for 3 billion years, you get something large. But models have struggled to comfortably produce something as large as TON 618 without extraordinary conditions. TON 618 exists at a redshift that places it in the early, gas-rich universe. The raw material available was more abundant. The density of matter was higher. The black hole may have had access to feeding conditions that no longer exist anywhere in the universe today. Mergers with other black holes, episodes of super Eddington accretion, feeding faster than the theoretical limit by brief, violent bursts, and possibly a very massive seed black hole, formed not from a single dying star, but from the direct collapse of an entire cloud of primordial gas. None of these solutions is fully satisfactory on its own. And TON 618 is not alone in posing this problem. Every ultramassive quasar discovered in the early universe pushes harder on the same question. How did things this big get this big, this fast? We don't fully know, and in that gap between observation and understanding lives one of the most exciting open problems in modern astrophysics. Here is something the YouTube thumbnails don't tell you. The mass of TON 618 is not a settled number. The 66 billion solar mass figure, the one most commonly cited, comes from a 2004 analysis by Ohad Shemer and colleagues, using the width of the H-beta spectral emission line as a proxy for how fast gas is moving in the broadline region near the black hole. The faster the gas, the stronger the gravity holding it in place, and the more massive the black hole. But measuring emission line widths in distant quasars carries uncertainty. Different lines give different answers. A 2019 analysis using the CIV emission line instead produced a figure of approximately 40.7 billion solar masses. Still staggering, but meaningfully different from 66 billion. Both measurements are real. Both are legitimate methods. The difference reflects how genuinely hard it is to measure the mass of an object you cannot see at a distance of 10.8 billion light-years through billions of years of cosmic expansion. What both estimates agree on is the scale. Whether the answer is 40 billion or 66 billion, TON 618 is in a category so far above ordinary supermassive black holes that some astronomers have proposed a new term entirely: ultramassive, a category separate from the supermassive black holes at the centers of typical large galaxies, like Sagittarius A, at 4 million solar masses. TON 618 is between 10,000 and 16,500 times more massive than the black hole in the center of our own galaxy. Not 10 times, not 100 times, 10,000 times more massive. In the same universe, by the same physical processes. That gap in scale is still something astrophysicists are working to fully explain. Here is the question no one asks, and the answer is quietly extraordinary. What is TON 618 doing right now? We cannot know, because the light we're seeing today left TON 618 10.8 billion years ago. Everything we know about it, its luminosity, its jets, its accretion disk, is a 10.8 billion year old snapshot, a photograph taken when the universe was barely 3 billion years old, and TON 618 was at the peak of its violent youth. In the time since that light left TON 618, our own sun has formed. The entire 4.5 billion year history of the Earth has played out. Human civilization has risen. We built telescopes. We pointed them at that faint blue dot in the sky, and spent decades working out what it really was. And all of that time, TON 618 has continued existing, evolving, changing. 10 billion years of its history are simply hidden from us, behind a wall of time too thick for light to have crossed yet. What is the most likely fate? Quasars burn brightest when gas is plentiful, but gas is finite. As a black hole consumes its surrounding fuel supply, the accretion rate drops. The disk dims. The jets weaken. The blazing quasar slowly fades into something quieter. If TON 618 followed the same trajectory as other massive early universe quasars, and astronomers have good reason to believe it did, then today, in the present universe, it is no longer a quasar at all. It is probably a dead giant, an enormous, dormant black hole sitting at the center of a large elliptical galaxy. Silent, dark, no longer consuming at any appreciable rate. The jets long since faded, the accretion disk cold and dispersed. The thing we call TON 618, the blazing, hyperluminous engine of the early universe, may have already ceased to exist billions of years before the Earth was born. What we're observing is not what is, it's what was. The most powerful object ever confirmed by human science is a ghost. TON 618 is not just a record, not just a spectacularly large number. It is a message. Quasars like TON 618 are only possible in the early universe. When galaxies were young, gas was abundant, and the raw fuel for black hole growth had not yet been consumed or dispersed. They represent a phase of cosmic history that our own galaxy has almost certainly passed through. The Milky Way, today, has a quiet, 4 million solar mass black hole at its center. But astronomers believe that in its youth, 10 or 11 billion years ago, it too may have blazed as a quasar, consuming gas at rates that would have made it visible across the universe. Every mature galaxy we live near may be the corpse of something that was once, briefly, as violent as TON 618. And here is the deeper implication. If TON 618 scale black holes exist, and we've confirmed that they do, then they must have formed, grown, and fed on timescales the models are still struggling to accommodate. The universe, in its infancy, was capable of producing mass concentrations this extreme within only a few billion years of the Big Bang. That means our understanding of how matter organizes itself, how gravity amplifies and feeds on itself, how the first generation of black holes seeded everything that came after. All of it is still incomplete, still being worked out, still producing surprises. TON 618 is not just the largest thing ever confirmed. It is a question, written in light that is 10.8 billion years old, addressed across incomprehensible distance to whoever happens to be listening. The Tonantzintla Observatory is still there, a small building on a hilltop in Puebla. Tourists pass through. The old photographic plates, if they still exist somewhere in an archive, contain entry number 618, catalogued as a blue star, unremarkable. That small blue dot on a photographic plate, that misidentified mark in a catalogue, filed by two astronomers who could not have known what they'd found because the concept for it hadn't been invented yet. That tiny smear of ancient light, released when the universe was barely 3 billion years old, carrying the signature of a darkness surrounded by the fires of 140 trillion suns, crossed 10.8 billion light-years of expanding space, bent around galaxies, threaded through the cosmic web, outlasted entire stellar civilizations, and landed on a photographic plate in Mexico as a small blue dot. That was the first time TON 618 and humanity made contact. We had no idea what we were looking at. We spent decades figuring it out. And now we know. In a universe 13.8 billion years old, still mostly dark, still mostly cold, still mostly empty, something like this existed. Something this large, this luminous, this violent. And the fact that we can sit here, on a small rocky planet, orbiting an ordinary star, in one unremarkable arm of a quiet galaxy, and know that is the strangest miracle of all.